How to transfer quantitatively. For quantitative transfer, the following materials are required: a beaker with a chemical, a solid to be dissolved, a measuring flask and stopper, a glass stirring rod, funnel, paper clip, bottle with demi-water, Pasteur pipette, and paper. The solid is dissolved in water or another suitable solvent. You can use a glass stirring rod to dissolve the solid. The stirring rod should remain in the beaker. Dissolving occurs at all times in a beaker. If the substance does not dissolve, then you can simply heat the beaker on a hot plate. Before the solute can be transferred into a graduated flask, all glassware must be flushed with tap water 3 times and 3 times with demi-water or any other possible solvent used, for example ethanol. The funnel is placed in the flask with a paper clip in between. As soon as there is liquid in the flask, the air must be able to escape, and this can be done through the outside of the funnel. The stirring rod is placed at the mouth of the beaker. Your index finger holds the stirring bar in place. The other hand rinses the beaker with demi-water from the squeezy bottle. The liquid is transferred in a smooth motion into the funnel. The beaker can be rinsed 3 times with demi-water, and then the stirring rod and the funnel can also be rinsed. Ensure that not too much liquid is added because otherwise the flask will be too full. The funnel is removed and the neck of the flask is rinsed with demi-water. Ensure that the tip of the squeezy bottle does not touch the measuring flask. The measuring flask is filled with demi-water to approximately 1 centimeter below the line. A small piece of tissue is placed around the clean and dry stirring rod to dry the neck of the flask. The neck is only dried above the line. Using a Pasteur pipette, the solution is filled until the meniscus is brought to the line. A clean and dry stop is placed in the measuring flask. Finally, the solution is homogenized by inverting the solution 10 times. The solution is now ready for use. Sometimes there are air bubbles in the solution after homogenization. This is not a problem if the solution is homogeneous.